Hello everyone. Welcome back to our series where we are covering NCERT problems. Here we will cover question number 3.9, 3.10, 3.14, 3.18, 3.24 and 3.25 from 11th standard physics book. So let us begin. Question number 3.9. Two towns A and B are connected by a regular bus service with bus leaving in either direction every t minutes. So, from station of town A, bus leaves every t minutes, and from station of town B, bus leaves every t minutes. Okay. Now, a man cycling with a speed of 20 km per hour. So, VC, which is speed of the cyclist, has been given to be 20 km per hour. So VC has been given to be 20 km per hour in the direction of A to B. So the cyclist is moving from A to B, notices that a bus goes past him every 18 minutes in the direction of his motion. So bus coming from A is passing him every 18 minutes and every 6 minutes in the opposite direction. So bus coming from B is passing him every 6 minutes. We have to find period T of the bus service and the speed of the buses which lie on the road. Okay, so let us assume speed of the bus is V. So let us assume their speed be V. Speed of bus is V kilometer per hour. Speed is V kilometer per hour. Now, as the bus is passing the cyclist, we will calculate first the distance between two buses. Now, if bus leaves every t minutes, so distance d between every bus will be speed of bus v multiplied by time period t, which is vt. Vt is the distance between every bus. Now, what will be the relative speed of bus in the direction of the cyclist? So V from A to B, relative speed of bus from A to B with respect to cyclist will be speed of bus minus speed of cyclist, and from B to A, because the bus and the cyclist are in opposite direction, we will have to add their speed, so it will be V plus VC. Now this will be the speed at which the cyclist will find the buses moving, and with this speed every bus crosses him in 18 minutes, and with this speed bus crosses him in 6 minutes, and they would have distance Vt among them. Therefore we would get Vt is equal to V minus Vc into 18 minutes, which is also equal to V plus Vc into 6 minutes. Therefore, we will get V minus Vc upon V plus Vc is equal to 1 by 3. But we know Vc is equal to 20 km per hour. So, upon simplifying, we get V is equal to 40 km per hour. So upon simplifying, we would get V is equal to 40 km per hour. Now to find the time period, therefore time period T will be V plus Vc into 6 upon V. So this will be 40 plus 20 upon 40 into 6, which will come out to be 9 minutes. So time period is 9 minutes and velocity of the bus, or the speed of the bus, which we are assuming is constant, will be 40 km per hour. Okay. Now let us look at question 3.10. A player throws a ball upwards with an initial speed of 29.4 meter per second. So initial speed u is 29.4 meter per second. Initial speed u is 29.4 meter per second. What is the direction of acceleration during the upward motion of the ball? See, the only force acting on the ball is the force of gravity. Therefore, direction of acceleration will always be towards the ground. So it always be towards the ground. Then second one, what are the velocity and acceleration of ball at the highest point? All of us know at the highest point, the ball will be momentarily at rest because it has been thrown with some velocity. The velocity will go down, 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 momentarily at rest at the highest position and then go on increasing. So at the topmost position, velocity will be 0 and acceleration will be what it was initially, which is gravitational acceleration g. So it will be 9.8 meter per second square downwards. The acceleration will be downwards. So acceleration g will always be downwards. Then the third question, we are choosing x is equal to 0 and t is equal to 0 at location and time where ball is at highest position. So at this position, at highest position, we are choosing x equal to 0 and time equal to 0 and vertically downward direction as positive. So we are considering this direction as positive. Give the signs of position, velocity and acceleration of the ball during its upward motion and downward motion. So upward motion, downward motion. First we need signs of position. Position in upward motion will be positive because this level is 0, everything below it is positive. So ball will decrease its positive value in position. So position will be still positive, downward direction also position will remain positive. Velocity will be negative because it is in the upward direction initially, and while it is coming downwards it will be positive, and acceleration will be positive in both cases. Acceleration will be positive in both cases. Now let us look at the fourth part. To what height does the ball rise and after how long does the ball return to the player's hand? Now initial velocity is u. Initial velocity is u, which is 29.4 meter per second. Height raised is h. Acceleration is 9.8 meter per second square. Acceleration is 9.8 meter per second square. Therefore, h will be u square upon 2g. So, which is 29.4 into 29.4 divided by 2 into 9.8. So 9.8 ones are 9.8 threes are. So it will be 3 into 14.7. So it will be 44.1 meters. So maximum height reached would be 44.1 meters. And what would be the time taken? Time taken would be 2u by g. Time taken would be 2u by g, which is 2 into 29.4 upon 9.8, which is 58.8 upon 9.8. So this is 6 seconds. So time is 6 seconds. Now let us look at 3.14. A man walks on a straight road from his home to a market 2.5 kilometer away. So HM is 2.5 kilometer. HM is 2.5 kilometer. So initially speed V1 is 5 kilometer per hour. Speed is 5 kilometer per hour. Finding the market closed, he instantly turns and walks back home with speed of 7.5 kilometer per hour. 7.5 kilometer per hour. We have to find magnitude of average velocity. So, as the man has returned to his original position, the displacement is 0, therefore average velocity will be 0. 0 meter per second as no net as there is no net displacement. Average velocity will be 0. What about the next part? So we have to find average speed. Now see, we have to find average speed, which is the total path traveled divided by total time taken. So that will not be 0. Velocity, average velocity will be 0. Average speed will not be. So from 0 to 30 minutes. Now if we consider his motion for going to the market, time taken, that is time taken to go to the market, is 2.5, which is the distance, divided by speed 5, which is half hour, which is nothing but 30 minutes. Therefore the person is walking 30 minutes with speed of 5 km per hour. His speed is not changing, therefore average speed at the end of 30 minutes, that is average speed from 0 to 30 minutes, will be 5 km per hour. So average speed will be 5 km per hour. Second one in that, what do we have? From 0 to 50 minutes. So he takes 30 minutes to reach the market. Let us find out how much time does he take coming back. So if T2 is the time required to come back, it will be equal to 2.5 divided by speed while coming back 7.5 km per hour, which is 1 by 3 hours, which is equivalent to 20 minutes. Which is equivalent to 20 minutes. So the person takes 30 minutes to go, 20 minutes to return. So total distance traveled is 2.5 while going, 2.5 while coming. So total distance is 5 km and total time taken is 50 minutes, which is 50 upon 60 hours. It will be 5 into 6 upon 5, which is 6 km per hour. So speed, from average speed from 0 to 50 minutes is 6 km per hour. Now we also have to find average speed from 0 to 40 minutes. What? Average speed from 0 to 40 minutes. 0 to 40 minutes. So this will be directly total distance traveled. Total distance traveled would be 2.5 kilometer, which is the first half of the journey. Second half of the journey requires 20 minutes. So in 10 minutes, half of the distance will be covered. So 1.25 kilometer and time taken is 40 minutes. So 40 by 60 hours. So this will give us 60 multiplied by 3.75 upon 4, which gives us 5.625 kilometer per hour, which gives us 5.625 kilometer per hour. Therefore, from 0 to 30 minutes, average speed will be 5 kilometer per hour. From 0 to 50 minutes, average speed will be 60 kilometer per hour. And from 0 to 40 minutes, average speed would be 5.625 kilometers per hour. Okay. Now let us move to the next question. Question number 3.18. A policeman moving on a highway with a speed of 30 km per hour fires a bullet at a thief's car speeding away in the same direction with a speed of 192 km per hour. If the muzzle speed of bullet is 150 meter per second, with what speed does the bullet hit the thief's car? So we have to find the relative velocity of the bullet with respect to the thief's car. Now first, let's convert all the speeds into meter per second. So we have velocity of police car, which is 30 km per hour. This would become 30 into 5 by 18, which is 3 is 5 is 25 by 3 meter per second. Now velocity of the bullet with respect to police car would be 150 meter per second. Therefore, velocity of the bullet with respect to ground would be 150 plus 25 upon 3 meter per second. 150 plus 25 upon 3 meter per second. Now, what is velocity of the thief? Velocity of the thief's car is 192 km per hour, which is equal to 192 into 5 upon 18. So 6 3s are 32. So it is 160 upon 3 meter per second. Now we just have to find what will be the relative velocity of the bullet with respect to the thief car. So velocity of the bullet with respect to the thief's car would be Vb minus Vt, because both of them are moving in the same direction. Therefore, we would get 150 plus 25 upon 3 minus 160 by 3, which is 150 minus 135 upon 3, which is 150 minus 45. So it will be 105 meter per second. So the bullet will impact the thief's car with a velocity of 105 meter per second. Now let us move to the next question. 3.24. A boy is standing on a stationary lift which is open from above, throws a ball upwards with maximum initial speed he can, which is equal to 49 meter per second. So maximum initial speed he can throw is 49 meter per second. It is 49 meter per second. How much time does the ball take to return to his hands? So we know total time taken by the ball to return would be, we are assuming g is 9.8 meter per second square. So total time taken will be 2u by g. Total time taken would be 2u by g, which is 2 into 49 upon 9.8, which is simply 10 seconds. Now the next part of the question is, if the lift starts moving up with uniform speed of 5 meter per second and the boy throws again with maximum speed he can, how long does the ball take? Now remember, with respect to the boy, initial speed of the ball would be 0 and he would throw it with 4.949. He would throw it with 49 meter per second. Okay, so the situation has not changed. For a person standing on the ground, they would feel that the ball has started with 54 meter per second and the boy will move up and then catch it a bit earlier. But for the boy, in his frame of reference, the initial velocity is just 49 meter per second. Therefore, in the second case also, the ball will come back to the boy in just 10 seconds. In just 10 seconds. There will be no change in duration of time. Very important to remember. In the frame of the boy, initial velocity is 0 and he is just throwing it up. with 49 meter per second speed. Okay, and acceleration is same as 9.8 meter per second square towards the ground. So there is no change in conditions. Therefore, again time taken would be 10 meter per second. Now let us move to the last question that we will cover today. On a long horizontally moving belt, which is shown in the figure, a child runs to and fro with speed of 9 km per hour with respect to the belt between his father and mother located 50 meter apart. So both father and mother are on the belt. The belt moves at a speed of 4 km per hour. For an observer on a stationary platform outside, what is the, so we have to write, so speed of the child running in direction of motion of the belt. So for an observer, the child's net speed would be speed of the child with respect to belt plus speed of the belt. So it will be 9 plus 4, which is 13 km per hour, which is 13 km per hour. Next, what do we have? Speed of the child running opposite to the direction of motion of the belt. So it would be 9 minus 4, which is 5 km per hour, which is 5 km per hour. Now in question C, we have to find time taken by the child while moving with the belt and moving in the direction opposite of the belt when he is going from mother to father. Now for mother and father, they too are moving with the belt. So the only speed that they will observe will be speed of the child on the belt, that is speed of the child with respect to the belt, which is 9 km per hour. So V is 9 km per hour, which is nothing but 9 into 5 upon 18, which is 2.5 meter per second. So this will be speed of the child from mother and father irrespective of the direction in which the belt is moving. So time taken would be, time taken T would be distance between mother and father divided by speed. So distance given is 50 meter, speed is 2.5 meter per second, which will lead us to time to be 20 seconds. So time that the child will take from one parent to other will be just 20 seconds. So we have covered a lot of problems of chapter 3. So let us meet next time when we cover chapter 4.